Look at number 7. Check out this piecewise function right here. This piecewise function is shown below. Okay. Well, we would graph it, but we don't know what c is. Normally we'd graph and we'd stop at 2 and then we'd pick back up at 2 and we'd draw this. This is a line, this is a parabola. But now the kicker is what this means. For what value of c does the limit as x approaches 2 of f of x exist? What? Okay, the limit is not the value at the function so much as it is the value when you approach, in this case, 2. And the real kicker with this problem is the left and the right must be equal. What in the world does that mean? Here it is. I'm going to draw a rough sketch of it. If we draw this side, it's going to go like this. And it's going to stop at 2 because it's a line. And then the other side, we're going to draw some parabola and it does this little thing and it goes like that. Okay? In this case, the limit, I'm about to quote Mean Girls here, okay? The limit does not exist. I've never seen that movie, by the way, but I do know about that quote. The limit does not exist. The reason the limit does not exist, it's hard to say that with a straight face. You can't even see my face right now. But anyway, the reason the limit does not exist, T, is because it's broken. As I approach from the left side, I get some positive value. Whatever, doesn't matter what it is. Just hypothetically with this graph, as I approach from the left, I get some positive value. As I approach from the right, it's some negative value. Doesn't matter what it is, but the fact is it's broken. So what it's really asking you to do is this. Find the value of c to where if you were to draw this, whatever that value may be, you would never have to lift your pen. And then when I'm doing this thing, I would say, well, as I approach from the left, it's whatever. I'm going to call it 2. Y value of 2. As I approach from the right, the y value is, oh my gosh, it's the same thing. How in the world do I do that? And can you say it again, Mr. Reader? Why, yes, I can. This had better equal this, where x is equal to 2. Okay? As we approach, when x is 2, they better have the same y value. So here's the deal. We're going to make an equation. Cx plus 1, top part, had better equal Cx squared minus 1, where x is 2. Well, what should I do? Plug in a 2. Man, I'm rhyming over here. C times x, and x is 2. So 2c plus 1 equals, we're going to plug in a 2, and we'll do it in my head. 2 squared is 4. 4c minus 1. Now we have a regular equation that we can solve. We're going to subtract 2 from both sides. From both sides. I'm suddenly Swedish. We subtract 2c. Those cancel. Subtract 2c. Add 1. Those cancel. Add 1. We get 2. 2c equals 2. c is equal to 1. And if we were to plug a 1 in for c right here, and we were to graph this, then we would never have to lift our pen when going from one piece to the other. There we go. The answer for C is 1, which is C. See?